All right now I'll be taking you through number 31 from 11.7. And so what we're going to do here is first consider the critical points. And for these, we need f prime, fx, and that's going to be equal to just 6x squared, and that we set equal to 0 to find a critical point. Likewise, we find fy, which is equal to 4y cubed. And so if that equals 0, we know one of our critical points is at 0, 0, and f of 0, 0 is just 0. All right, so now I have to check along my paths. So this is a circle, and I'm just going to go ahead and solve for y squared because it looks to be easier to plug in for y squared in my function than it would be for x cubed, or plug in for x here because it's cubed versus y squared is just you just have to square that to get y to the fourth. So let's find f of x comma plus or minus square root of 1 minus x squared. And that's going to be 2x cubed plus 1 minus x cubed squared, because if this is y squared right here, y to the fourth is just the square of that. So simplifying, I get 2x cubed plus 1 minus 2x squared plus x to the fourth. So on the path, my function is going to be x to the fourth plus 2x cubed minus 2x squared plus 1. Now, I'm looking to minimize and maximize in the domain. X goes from -1 to 1 because it's a unit circle right here. So I'm looking at what x value minimizes this particular curve and what x value maximizes it within this domain. And so it might help me to take the derivative of this. And I get 4x cubed plus 6x squared minus 4x. And setting that equal to 0 will help me find the critical points. I'm going to factor out an x. Actually, I'll do a 2x. So I get 2x squared plus 3x minus 2. And then it looks like our critical points are going to occur when x is 0 and also when 2x squared plus 3x minus 2 is 0. I'm going to factor this real quick. And so factoring that, I get critical points. Let me make sure I did that right. Yeah, that looks good. X equals 1/2 and -2. We know -2 isn't really valid for this because it's outside of our region. But if x equals 0, we know if x equals 0, that I can then solve for y. And when I look at x equals 0, if x equals 0, then I'm finding the value f of 0, comma, plus or minus radical 15. Actually, just plus or minus 1. So that's 1. And at f of 0, 1, we're just going to get 1. And then if we do f of 1/2, comma, plus or minus the square root of 1 minus 1/4, just plugging that in up here. I'm looking at f of 1/2 and plus or minus the square root of 3/2, or I'll just do it inside 3/4. And if I plug that in 1/2, what I'm going to get is 1/2 to the 4th plus 2 times 1/2 cubed minus 2 times 1/2 squared plus 1. I think that's going to be 8/13/16. So far in that region, I have 0, 0, which is 0. I have 0, 1, which is 1. And then I have this on the boundary. But let's consider the fact that I don't know if these critical points are going to be the minimum and maximum of this particular function. So the function I'm looking at is right here. So that could have critical points that aren't actually mins and maxes. So what I'm going to do is I'm going to take a look at the graph. So give me a moment while I bring up the graph. So I have x to the 4th plus 2x cubed. Whoa. Let's try again. X to the 4th plus 2x cubed minus 2x squared plus 1. And if I just click graph, this is the graph. So you can see that I have, let's see, at 0, I have a critical point here. Hopefully you guys can see my cursor here. This is just a little point of inflection, it looks like there. So that's not going to be super useful. And then I have 1/2, comma, x equals 1/2, which is right here. That is a local min, but it's not super low right there. So let's zoom in to x values, or let's change the x values to where we're looking. We're looking between -1 and 1. And if I hit graph, I can see that my lowest possible value at that point is right here. So in other words, it's x equals -1, and my highest possible value is x equals 1. So although I had critical points at x equals 0 and x equals 1/2, they were very minimal movement. One's a point of inflection, one looks to be just a local min here. And so f of -1 for x is going to provide a min, and f of 1 is going to provide a max. So because it's a bit more complicated of an equation, it was good to go to the graph. So let's look then at f of 1. Actually, I'll do the lower point was f of -1. So it was f of -1, comma, 0. And that's going to provide a value there of, let's see, -2. So that must be my minimum overall. Let me just do a little highlighter. I'm thinking that's going to be my min. Yeah, so far I haven't gone that low. And then if I look at the other point in that graph, that was 1. And 1, 0 is going to yield 2 as my max. And I'm getting those by plugging them into, you can plug them into this function here. That works, just plugging in 1 for x. Notice we get 2. Plugging in -1 for x, we're going to get -2. And so overall, through all of this work, finding the critical points, those ended up not being super critical. So this is our absolute min and our absolute max. And it looks like the critical point of the surface at 0, 0 ended up being not so important. It ended up being on the border. All right, if you have further questions, just let me know. Thanks.